Okay, good evening. Um, we'll continue our QA class. So under operational research, we'll be doing what's it called? We'll be doing transposition problem. So this is what we are doing today: transposition and assignment model. But I'm going to focus on transition model today and the assignment model another time. Okay. So let us start with transition model. I think I'll use the original pack. So transition model is a special class of linear programming problem. So and if you are conversant with operational research, you also know that linear programming problem is um an operational research is under operational research, and the major problem is you want to see how visible what you are doing, what uh, you are trying to do is you want to see how visible it is. So your objective function is to maximize profit or contribution and to minimize costs. Right, that's the objective function. Now, how does this relate to transition problem? The objective of transition problem is also minimize costs, but in what situation or in what circumstance? That's you meeting your demand. So you are trying to distribute a single commodity from various source to your destination. Understand? You're trying to meet your demands. So now, while trying to meet your demands, you are trying to bear in mind the minimum cost. The minimum cost. Okay. So the technique will involve identifying what you call an initial basic feasible solution. That's what I was trying to tell you at first, that you want to determine how feasible what you are doing is. And you know the meaning of feasible, right? So um that means is it, how will I explain the English? Is it possible? Like is it possible, and can the cost be controlled? That's the meaning of feasibility. What you are projecting or what you are foreseeing, is it achievable? Let me use that English, you understand? And how achievable it is. I hope you are getting it. So, and you can also use another English, is that is it practical to achieve? Okay. So all these are the terms you can use when you're trying to define visibility. So now, what is the nature of translation problem? I already said it's a special class of linear programming. I already described the reason why you are doing it. You are trying to meet up with what's your destination, which is your demand. You are trying to meet your demand at minimum cost. Then this is how a transition problem will look like. Okay, so the transition problem, the transition problem. So let me check it out. See recording. Okay, I'm still recording. I'm still recording. So the transition problem, or okay, your demand must be equals to your supply. Your demand must be equals to your supply. So it means this place must be the same thing. If it is not the same thing, there is an issue. So if it is not the same thing, that's the first thing you are going to tackle first. That's the first thing I'm going to tackle. So let me show you. Let's see if this is correct. So your exam, when you have a question like this, first thing is to check your demand and your supply. So let's check our supply side. That is 5 plus 60 plus 48. That's given us 193. Let's check the demand side also. 51 plus 72 plus 36 plus 34. That's also 193. So as you can see, it is the same. Then you ask yourself, what if this is not the same? So that takes us to the next thing we want to do, which is called an unbalanced transportation problem. We have balanced and unbalanced. So like this first one is a balanced equation. Now an unbalanced equation is a situation whereby the demand is not equal to supply. Now if you see this question, you see that they have to introduce what you call dummy. Dummy is usually or mostly introduced when one side is greater than the other. Now, if you see this question now, 40 plus 60 plus 40, this is 140 without thinking of the dummy because dummy was used to balance. So let us think of the dummy now. Let's just think of the other things. So this is 140, then this is 50, 90, 90 plus 80, 170. So this is 140, this is 170. So it means that this side needs 30, be a balance of 30. So that's why they use dummy. So in your dummy, all these ones, all these are your costs. So in the dummy, all this will be 0, 0, 0, 0, right? Then you have the 30 balance. That's because it is this side that is missing the figure, right? If it's also this side that is missing the figure, let's say it was demand that was not complete. You just put dummy here to 0, 0, 0. You impute the what's it called? You impute your missing figure. Okay. You also impute your missing figure if that's the other side. So you use missing figure either for the row or the column, depending. Use dummy on the row or on the column, depending on where the missing figure needs to be balanced. Okay. So that is another thing that you should know. Okay. So after that, we'll go to okay, I wanted to tell you about this Hungarian method, but that's for assignment as long as assignment problem. So there's not really much theory on what's it called transition problem. So that brings us to the methods of calculating initial basic feasible transition costs. Okay, so how do you or which method do you use to calculate the transition problem? So we have three basic method. So the first one is northwest corner method. But before we start that, let me just quickly say this. So for you to know that your solution is correct, note that any of the three methods must satisfy the following condition in order to obtain the initial visible basic solution. The problem must be balanced, and I already told you what a balanced problem is. Your demand is equal to your supply. The number of cell allocation must be equal to m plus n minus 1, which m is what? Rows, and n is columns, respectively. Okay. So any solution satisfying the two conditions is termed non-degenerate degenerate non-degenerate initial basic feasible region. So they can ask this in your OBJ filling the gap. Otherwise, it is called the degenerate problem. Okay. So let's quickly go to the big deal, which is our methods of preparing transition problem. So the first one is the northwest corner, and that's the simplest but the most inefficient, you know, and it will give you the highest cost. What I mean by the highest cost is that what I mean by the highest cost is that by the end of the day, when you can use the tree to calculate its cost to be very high. Okay. Mm, and the reason why it's like that is because It does not take into account all the alternative routes. I just starting from the northwest cell. And let me quickly explain how that can be. Um, if you look at this, if you still remember how you still remember in your geography, you have something like this: north, south, west, east, right? I have north, south, west, east. So this is our northwest, right? This is our northwest. So when we say we are doing northwest corner, that means we are going to start from this angle, this upper last angle, top left hand cell. Let me put it like that. And we'll start allocating the cost to each cell, trying to meet all the demands. So that's just the basic thing we want to do. So once a cell is exhausted, we move, keep moving till we exhaust everything. So let's take a question first on the northwest corner method before we move to any other method. And the question I'm taking is this method, is this question. So I'm using this one question to solve both northwest corner method, least cost method, and Vogel approximation method. So when I finish northwest, I would explain this cost also and Vogel approximation. So I'm going to copy this into our worksheet that I want to use. So I've already draw out what we need. Okay. So let's put the question just at the side so that we won't have to be going back and forth. Let me see if it can work. Good. It worked. So I think moving on forward, I'll be using this style because I feel this style is easier than sharing screen every time. Okay. I'm gonna let me see if I can still make it a little bit smaller. I think it looks like this. I hope you'll be able to see everything. Uh-huh. Okay, good. So um I said SCO company has three plants or location ABC where its goods can be produced with a production capacity of 50, 60, 50. When I say production capacity, that's the number, that's the amount that you can produce, or that's the quantity you can produce, right? And that's the quantity you can also supply. Cannot go beyond that. So 50, 60, 50 is your supply. You understand? So they will not tell you, sometimes they will not tell you this is their supply, but the terms, and according to the term here, production capacity, you know, okay, this is our supply per month, respectively, for a particular product. Okay. These units are to be distributed to 4 points X, X, Y, W, Z. Those are the destinations of consumption with the demand. This one I told you demand. But if they don't tell you demand, they can also give you another term like requirements. The requirement of that same thing as your demand. Okay. That's 50, 70, 30, 10 per month respectively. The following table gives the transaction cost in naira from various plans to various points of consumption. So obtain the initial basic feasible solution using the following methods. So this is good. Okay. So how do you get this? So you impute all of this back into this. So this would be 21. Impute all the figures back. Impute all the figures back. That's 21, 18, 27, 22, 19, 18, 24, 20, 24, 25, 28, 25. Yeah. So listen carefully from here. Okay. So let me see if I'm still recording. Okay, I'm still recording. You now start. I don't think I even need this question at this point again from here. I want you to see it very well. So you now start from northwest. This is northwest corner. So where is your northwest? This is your northwest. Okay. So what is the demand that your customer will need? They need 50 demand. What do you have as a capacity? What can you supply them? That's also 50, right? So what does it mean? This means that you can give them what they want, right? Since you can give them what they want. So you now come here, since you are giving your demand all the 50, since that's all they need, you now cancel it out. Okay. So it will become 0. So this will become 0. Then since then you are giving it out, so you now have another box here. Let me just use this as my box. Okay. You now write the 50 inside. This thing's too big. Okay, so that's the 50 inside. That means you have given the 50 to this cell. So you now cancel the demand too, since you have met the demand. Let me first write 0. So, sorry. So that's the first thing. You are done with that. So what we now do, you look at it. That means this whole cell, this whole place is already cancelled out. This row is already cancelled out, right? Because there's no more supply. Then you look at this column too. The whole column is already cancelled out because there is no demand again. This whole column is already cancelled out because there's no demand. So you are not going to put anything into all of this space again and all of this space again. So where is the remaining place you need to focus on? That means all of here. These are the remaining places that you need to focus on. So you continue again from the northwest. Again, from here, you look at it again. What is our supply? 60. What is the demand that they are looking for? 70. Abi? So 70. We give what we do not have. So let's give them what we really have, which is the 60. So can I say this is 0, right? Then this will be cancelled out, right? So in this place, we will show that we'll give them the 60. We should have given them the 60. Let me just copy and paste to this place, right? Yes, so we it should be on this side. Yeah, it should be on this side. And we'll cancel the 50 to 60. Okay. Now we'll come to this place. I need it to, sorry, I need this thing to be well set. Good. Then you come to this place. We have already attended to 60 demand out of 70 demand. So it will remain what? It will remain 10. So it will remain 10. Then you cancel out this also, right? So it means this place is all cancelled out. This whole road is all cancelled out. This whole road is all cancelled out. This column is cancelled out. So where would it remain? It will remain one, two, three. All this is cancelled as zero already. All this is cancelled as zero already. All this is cancelled as zero already. So it means one, two, three. So you start from this place again. They only need 10 now, but you have 50 supplies. So you now give them 10 out of the 50 supplies. So if you give them 10 out of 50, it will remain 40 in your supply. Then you will now cancel this out also and bring 10. Okay. Okay. So sorry, it's 10 down to like there. I'll change it 10. Okay. So now that I've given them the 10 from this 50, this 10 will now become 0. So that has become 0. Okay, you look at this demand too, because you must meet all your demand. If you met this one, you've met this one. In this place, don't forget this place is cancelled out, this is cancelled out, this place is cancelled out, this place is also cancelled out. So it means 1, 2. And if you look at what we need here, 30 demand for W, 10 demand for Z, 30 plus 10, 40, and the supply is 40. So just give this 30, just give this 10, and it is straightforward. So let's start with this 30. So we want 30 demand, and we have 40 supplies. So if you remove 30 from 40, it will remain 10. Then you can remove this. It's not needed. This is Control C, Control V. So this one will become 0. Okay, so the last one is 10. Just impute that and we are done. So we give 10 supplies to 10 demand. There will be nothing left. Again, we have covered all the demands and we have covered all the supplies. Okay, so you put the 10 here also. So this one will also turn to 0 since we met the demand. And as you can see, we have met all our demands 0, 0, 0, 0, 0, 0, and we've exhausted all our supplies. So this also turns to 0. Okay, so that's how we do it. So now let's also quickly get our costs. want to get our total cost. So how do we get our total cost? We now say total cost equals, you now pick all of these cells. You pick all of these cells one after the other. Okay. So that will now be, let's start with the first one. 21 times 50. We can put the 50 into bracket plus, this is the first one, 21 times 50, 18 times 60, 60, then plus 25 times 10, plus 20 times 30, plus 25 times 10. So what would all this one give us? Can I even put this thing on the system? Let me see. Don't think I enter my calculator. But if it does, I'll be so happy. Invalid inputs. Wow. Okay. Let me see another way to do it because I don't want to be pressing it on after the other. Let me see. Let me do something. Let's do something. Two 420. Is this correct? I don't think it's correct. Let me calculate it first. Let me use my own calculator to calculate it because this one I cannot use this one to calculate it. So using my calculator, 21 times 50 will give me 1050 naira plus 18 times 60, 1050 naira plus 25 times 10, that's 250, plus 20 times 30, 840, 840 plus another 250. And that's the end of Solomon Grande. That's 3470. I knew this was not correct. 3470, right? So that is our total cost. Okay. So this, and as you can see, this is a degenerate question because, so this is a degenerate visible solution because your demand equals your supply, and when you look at your row and your column, this is 4, 1, 2, 3, 4. Your row is 4 and your column is 3. 4 plus 3 is 7 minus 1. 7 minus 1, that's 6. So, and if you count your solution, 1, 2, 3, 4, 5, supposed to be up to 6, including this total. So, according to the form, it was it, will I call it a formula? I showed you something. Not here. Let me go back to what I showed you. Yeah, so the number of cell allocation must be equals to n plus n minus 1, where m and n are rows and columns respectively. Understand? Um, so let's go back to that question. So m is a m is 1, 2, 3, 4, 5. M are rows 1, 2, 3, 4. And 1, 2, 3. 7 minus 1. 6, 2, 3, 4, 5. This is 5. That means it didn't meet up with the second requirement. This didn't meet up with the second requirement. Okay. But at least you understand this is the correct solution. Although this didn't meet up with the second requirement. Okay. So what do I want to do? So in the exam, sometimes they can ask you something like, what is the initial visible cost in cell XA? Cell XA. So how will you know the initial visible region in cell XA? This is cell XA. So that's the 21 times 50. Whatever this answer give you is your answer in that one. Or they can ask you what is your visible region in cell CY. This is your cell CY. So that's 25 times 10 to 50 to 50. So I don't think there's anything big there. Can I just copy and paste this? But okay. Think I have all the other stuff there. Let me just copy this. So the next thing I want to do is list cost method. So I'm going to remove all these jargons. Mhm. This is not how to do. So that I'm coming. How to remove all this one so that I will have a clean sheet. How is this thing doing like this now? Let me just put this one here because I need to copy and paste. Okay, so now how do you do the least cost method? From the word least cost, that means the smallest. So in this method, the cheapest route is always the focus of the allocation. Cheapest. The first one is northwest. Okay, so it starts from the northwest corner. This one is the cheapest, the one that has the smallest cost. So it is a better method compared to northwest because costs are considered for allocation. Let me read that again. It's a better method compared to northwest corner method because costs are considered for allocation. Yes. So, like I said, you start from this least cost, then you keep on exhausting all the rows and columns till you finish. Let's jump into it. So, we are using the same question that we used before. So, this is what we're still using. Okay. So, how do you now do this? How do you do this? So, start on this first row. What's the least cost here? That's 18. We have 50 supplies capacity and we want to meet 70 demand. But can we do that? No. So we just give them the 50 that we have like that. So we are exhausting all these 50, right? So we are exhausting all these 50 and we are bringing, let me just create another shape. Let me say this. This can be in another way in your exam. You understand? What I mean by can be in another way in your exam is that, let me show you something very quick. I'll see the way they did their own. You understand? Their own cost was inside the box. Meanwhile, the allocation was in circles. My solution was out in this box. It's like outside the box, and my allocation was inside the box. Any way you want to use it, there's no, they cannot penalize you for putting one inside the box or one outside the box. Just do it in the possible best way that I can do it. You understand? It's still going to give you the same thing actually. So I prefer doing it like this, putting the allocation inside the box, because I don't want to do, all I don't want to do is I don't want to have a lot of box, right? So because I'm using Excel, so that's why I'm doing it like this. But it's still correct. Okay. So let's cancel this because we've given them 60 out of the 70 that they need. So it will remain 20. 20. So let's cancel this out. Okay. Think we are moving right. So let me check the percentage. All of this place like this cut off. Only this place. So we still have all of this row here in 19 and 20. Okay, so we'll come here again and we'll say which one is the least. Still 18. 18 is still the least. So what does 18 need now as demand? 20. But we have 60 supplies. So we'll give them the 20 that they need. So 20 minus 60, supplies will remain 40. So give them this, cancel it. We are giving them 20, right? So come here. Let me draw my shape again. So like the way I'm moving those shapes is somehow okay. Okay, so that's 20. Then we'll come here and cancel the 20. So once you cancel the 20, it becomes 0. So this also goes. So what I'm focusing on now, we have all this place cancelled out, all this place cancelled out. This place, let me show you very well. Cancelled out, right? Because that's become 0. We have all this place cancelled out also because that's become 0. So where left do we have? We have here 1, 2, 3, 1, 2, 3, right? So that means this space is not yet exhausted. This space is not yet exhausted. Just the space that is exhausted. So we'll continue from here. So the next list number is 19. And under 19, we have demand of 50, right? We have demand of 50 and we have 40 supplies. So let's give them what we have, right? So we give them the 40 supplies, it becomes 0. Cancel out the 40. So we bring the, sorry. So bring the 40 here. Bring the 40 there. We come here. It's giving you 40 out of 50. So it will mean 10, right? Okay. So it means what do we have again? This whole place is already exhausted. This whole supply is exhausted. This one too is exhausted. It means 1, 2, and 3, right? And if you even check, this is 10, 30, 10. 10 plus 30 plus 10 is 50, and the last thing here too is also 50. So most times everything will balance. Okay. So let's do this one to the next list, which is 24 there. So where is that my shape again? So we want to remove 10 from 50 to remain what? To remain 40. 40, right? So we'll bring the 10 here where it is needed. Then we'll remove this. This will become 0. Okay, so it remain 1 and 2. It remain 1 and 2. So let's quickly turn to 25 because that's next list. So that's also need 10. So remove 10 again from this 40. Remove 10 again from 40 to remain 30, right? So we'll give this our 10. We'll give it our 10. Then this will become 0. Okay. Then the last place is here, which is this 30, demand of 30. So we'll give it all our supplies. Our supplies become 0. We'll meet all the demands, right? So we'll also give it this shape. Oh, sorry. That's the one I'm supposed to do that. This is how I'm supposed to do it. I've forgotten. Oh, I've forgotten that. Sorry about that. So this is 30. Then we would transfer 30 since we meet all our supplies. All our demand, sorry. So and with that, we are completely done. So what we'll do is that let me copy and paste this, then I will change the calculation. So let's get our total cost. So to get that, that will be, let me cancel this one. So start on this first one, 18 and 50. 18 times 50. Ma, okay, sorry about that. Where did we stop? Okay, I think I'm on exam. Okay, 18 and 15 plus. What's the next one? You know that you can just calculate it anyhow you like. That's 18 times 20 also plus 19 times 40 plus 24 times 10 plus 20 times 30 plus 25 times 10. which you give us, you calculate it with your calculator. 18 times 50, 18 times 20, 19 times 40, 24 times 10, 20 times 30, 25 times 10. Okay, if you calculate everything now, this should give us 350. Yes. If you look at this one now, this one is um if you check what I explained to you before, let's go back to what I explained. If the two conditions is satisfied, it is non-degenerate. So that second one that we did is non-degenerate. N plus one minus n plus n minus one. So if you see this place now, what we did now, rows and column 4 plus 3, 7 minus 1, that's 6, right? If you see the number of allocation 1, 2, 3, 4, 5, 6, this one is complete, unlike the northwest, which is just 5. So that's one of the reasons that they will tell you that not least cost is better than northwest, because first of all it gives a lesser cost. um then again it is more will I say it's more accurate. Yeah, let me put it like that, it's more accurate. So the last one is the Vogel, with Vogel approximation method. The Vogel approximation method. Another the Vogel approximation method, you use something called your penalties. Penalties. There's something called penalties. So let me see how I can use this. I don't need this thing again actually. So let me remove this so that I can do what I want to do. Um, good. So even this one, sef, I don't need this also. So let me now do what I want to do here. I want to do the penalty, what I'll need for the penalties. So I'll call this row penalties. Mhm. Row penalties, right? Then I also have column penalties. Okay. Okay. So let's continue. It's the same information to that I'll use here. So let me copy this also. So now, how do you do your penalties? What you do is that the first step is that you look at the two least cost, minus it from each other. That is 18 and 21. From here, can you see it? You do it for the row and you also do it for the column. That's how I call it, row penalty, column penalty. So for the row here now, here, here, The least is 18 and 21. So 18 minus 21 is what? That's 3, right? 19, 20, 21. Good. So we write 3 here. So that's for the first row. You do it for the second row also. Because the two lists, 19 and 18, that's one. Abi, that's one. You do it here again. Because the two lists, 24 and 25, that's also one. You are done with all the rows. Why is this thing having border? Come, I don't want it to have border. So you come here again, you do the same thing. What was the two list cost here? 19 and 21. That's 2, right? That's 2. Sorry, 2. This one, what's the two list cost here? 18 and 18. 18 and 18. 18 minus 18, 0. This one, what's the two list cost here? 24 and 27. This is also 3, right? Then this is 22 and 20. This is 2, right? So you now ask yourself that what is the highest? What's the highest number between this and this? The highest number is what? 3. Abi, good, it's 3. But this 3, we have 3 here. Also have another 3 here. So the next question is, which 3 will you start to use? Is the 3 that have the least cost? Is the 3 that have what the least cost? So if we check this 3, what's the least in this one? 21, 18, 27, 22. So the list is 18. Abi, if we check the 3 here, what's the least cost here? Is 24, which means 18 is smaller than 24. So just go for this row first. Start. So it means I'm going to start from here. You now go to the least cost. Don't forget how we started everything. We first minus the two least costs. We got all the penalties. Then we now pick highest. Assuming this one was 4, we'll have not even be checking which one is the list here or list here. We'll have just say, okay, this is 4. Let's start from 18. But we have to first check because we have two high numbers. Okay. So we're going to start from 18. So what is the demand for 18? 70. What is supplies that we have? 50. So we'll give them that 50 first. Okay. You see that I'm still recording. Okay, so then we'll come here, we'll give it a 50. Then we'll come here and 50 minus 70, 20. So what we need to satisfy now remains just 20. Um, so we have finished the first step. We'll continue like that the second step. So now how do you want to continue the second step? Don't forget this one have become 0. So you cannot do penalty for this again. So the only thing you can do penalty for is all of these remaining ones. Okay. Then you cannot do penalty. Okay, yeah, all of these remaining ones are the one you can do penalty for. Okay, so it means all this one will be dash, 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 dash. So since we cannot do this one again, there will not be penalty here. So penalty will continue from here. So from here, what's the two list? 19 and 18. So which will give us 1, right? This one too is 24, 24 and 25, which also give us 1. Then let's move here. We cannot do this one also. It has become 0. So if you want to do penalty for this, you're only going to consider this place, not this place. So 19 and 24, this is like 5, right? That's 5. And this 18 and 25. That's 7. Let me to charge. Sorry. I'm trying to charge. Okay. Okay, so next one is this, right? This place. So we'll not consider this 27, 24, and 28. This is 4, right? This is 4. Then lastly, this. We'll not consider this 22. 20 and 25, that's 5. So like we did the first time, we also do again here. What's the highest in all this row and all this column? What's the highest number? The highest penalty is 7. So you pick 7, trace it up. When you trace it up, you go to the least cost. This is 7, we've picked 7. Oh, let me be circling the one that I picked so that you remember in your exam to circle anywhere you're picking, anywhere you're allocating from the penalty, please circle. The first one was from here. So let's circle that. How do we even circle this? I should not do that very well. This circle is so small. I think the space I gave this thing is so small. Sorry. Let me let me try to adjust everything so that I'm able to do what I want to do. I just want to mark it. Hmm. Don't know why this thing don't still. Or should I use? Okay, I know what I'll do. So let me do like this. Let me insert the shape, then I'll put the figure. Why is this circle so problematic like this? Okay, I think this is okay. Circle is giving me problem. So let me just copy and paste. So in this place now, 77 is the one giving us the highest figure. So let me just cannot be I'll be trying to do that again. So let me just put 7 in this place. So in this place, the highest is 7. Okay. Just don't mind me with my circle. Let me be back here with my circle. Hmm. So you now trace the 7 up. What's the least? It's 18. Abi. So what does 18 demand? 20. And we have 60 supply. So we give it 20. It remains 40 supply that would have. So we come here. I just send it like this. So we are giving this 20, right? 20. Then this will become 0. So moving on, this whole place is all cancelled out. It has become 0. This whole place is all cancelled out, has become 0. So where are the other places? We have 1, 2, 3, 4, 5, 6. So we'll continue the penalty again. This place is already cancelled out. So we cannot start from here. And this place is cancelled out. So we'll not also consider here. So now the next penalty is 90 and 20. 19 and 20, which is also 1. Then this place is cancelled out. So this 24 minus 25, which is also 1. Okay. So we'll come to this place also. 19 and 24, which is 5. This place is cancelled out, is 0, so we don't need to touch that again. Um, this place we will not touch this top. So that's just 24 minus 28, which is 4. Then lastly 20 and 25, which is 5. Right. So what's the highest number? We have 5 and we have 5. We have to 5. So we trace the first 5 up. The lowest here is 20. We trace the second 5 up. Lowest is 19. So we pick this. Right. So 19 needs demand of 50, but we have supply of 40. So we're going to give all the 40. So supply is going to become 0. So I'm going to do this, then give it 40. Uh, Then the demand is going to become 10 since we have made 40 demands. Okay, so that's going to become 10. So where did we pick it from? From this 5. Let me do my circle again. My annoying circle. You have to do it so that you know where you picked. all those things from. Let's do it. Let me redo it. So this will be 5. Mm-hmm. I just got what I wanted to do since. Ah, at Seattle. With this knife and now. Just leave it at that. So that's where we got the 5. So now this has become 0. So that cannot be regarded again. That's 1. This has been cancelled out. This has been cancelled out also. Abi. So just means 1, 2, 3. So most times, they will still tell you to go on with what's it called? With doing your penalty. But once me I get to this stage, this is the last stage. You just have 1, 2, 3, 10, 30, 10, which is 50, and this is 50. I don't do penalty again. But some textbook they'll still be doing penalty. I just feel it's not useful again. So I'll just allocate everything based on this cost. This 50, what's list 10, I'll be 24 January. So I will start from here. Hell of stressing ourselves. So I think it's the same. Okay, it's not. Yeah, it's going to be the same thing as was here. 10, 30, 10. 10, 30, 10, Abby. Let me just copy and paste. Let me copy and paste. That's what it's going to be. Because I'm using the list. This is what the last one is going to be. You can calculate it yourself. I use the list to do it. So all this one to become 0. So once you just get to that last point, you don't really need to do penalty. Just use your normal list costs method to do it. And we've already done it before. So that's why I just went to go and copy and paste. So we have done these are our penalties and then this is everything. So let's really take our total cost. So total cost equals to start with 18 and 50. 18 times 50 plus 18 times 20 plus 19 times 40 plus 24 times 10. I think we to have tried this call is already more than 1 hour. Has soon be done. This last one. 1,002 times 10, then 28 times 30 plus 25 times 10. So this is also 1, 2, 3, 4, 5, 6. So it's a non-degenerate visible solution. Okay. So if you calculate all of these, um, yeah, if you calculate all of these, all you're going to get is 3 3,000, 3,000 are we going to get in 2,350. You can see now it's almost the same thing as this 1850, 1850, 1820, 1820, 1940, 2410, 2830, 2510. So actually, from the look of things, it's like Vogel and least cost will give you the same thing. I hope this thing did not change. Sha. So if I was okay. Hope it did not change. Okay, I think it did not change. That's the way I drew it up or changing. Okay, so this is everything. So thank you. And I'm going to send the solution and the question. Then watch the video, watch it again. If you have any question, you can ask me. And thank you very much for staying till the end. Good night.